What if we could perform surgery on the planet itself? Not just small adjustments, but a major intervention to fix one of Earth's most critical climate systems. We're about to walk through a radical proposal to do just that. This is engineering on a truly global scale. Let's dive in. And get this, what we're looking at is based on a pre-feasibility proposal that was marked strictly confidential. So this is our chance to peek behind the curtain at a blueprint for what could be one of the most ambitious projects humanity has ever considered. Okay, so to really get our heads around the plan, we first need to understand the patient. And in this case, the patient is a vital system for our planet's climate, a system known as the AMOC. The easiest way to think about this is like our own bodies. We've got a circulatory system that moves blood, heat, and nutrients around, right? Well, the Earth has one too. And what you're looking at here, this huge network of ocean currents, is basically the planet's heartbeat, keeping temperatures stable all over the globe. Now, its formal name is the Atlantic Meridional Overturning Circulation, or AMOC for short. It's essentially a massive conveyor belt of water that carries warm surface water up north and then sends cold, deep water back south. It's like a giant thermostat for the entire planet. And what this system does is absolutely critical. It's the reason a place like London has relatively mild winters, even though it's on the same latitude as parts of Canada. At the same time, it sends cold water south, which helps cool and stabilize huge parts of Africa. The bottom line is the stability of this current is non-negotiable for millions upon millions of people. But here's the kicker. This incredibly powerful, life-sustaining system is now in trouble. It's at risk. And the culprit is something you might not expect: fresh water. Every single year, Greenland is shedding a mind-boggling amount of ice. We're talking about an average of 117 billion tons. And this isn't just frozen water melting. It's a massive flood of cold, fresh water pouring directly into the North Atlantic, right into the engine room of the AMOC. So here's the basic science of why that's a problem. The whole AMOC system works because cold, salty water is really dense. It sinks to the bottom of the ocean, and that sinking motion pulls all the warmer water behind it, driving the whole current. But this new meltwater, it's fresh, which means it's much lighter. So instead of sinking, it just sits on the surface like a lid, literally blocking the current and slowing the whole thing down. And the consequences of that could be, well, catastrophic. If the AMOC keeps getting weaker and eventually collapses, some climate models are projecting that parts of Europe could see their average temperatures drop by as much as 20 degrees Celsius. That's not just a bad winter, that's a world-changing, civilization-altering event. So when you're staring down the barrel of a potential catastrophe like that, conventional thinking just isn't going to cut it. And the proposal we're looking at offers a solution that is just as audacious as the problem is scary: a direct physical intervention in the system itself. Which, of course, leads to the multi-trillion-dollar question: how on earth do you even begin to think about restarting a stalled ocean current? I mean, it sounds like something straight out of a sci-fi movie, but the answer this proposal comes up with is, in principle at least, surprisingly simple. The core idea is actually kind of elegant. If the whole problem is that the fresh meltwater is too light to sink, then the solution is to just make it heavy again. And how do you do that? You put back the one ingredient it's missing: salt. And the process is laid out in 4 pretty clear steps. First, you'd produce massive amounts of salt from the surrounding seawater. Second, you reintroduce that salt into the freshwater layer. Third, that restores the water's natural density. And fourth, that newly dense water sinks, kickstarting the whole AMOC flow again. So the concept is pretty easy to grasp, but the engineering, okay. The engineering is on a completely different level. This is where we get into the blueprint, and the sheer scale of the challenge is almost hard to wrap your head around. Just look at these project vitals for a second. The amount of fresh water that would need to be treated is over 29 billion tons. To do that, you'd need about 1 billion tons of salt. And the energy required to make all that happen? A whopping 420 terawatt hours. The scale is just staggering. Now, 420 terawatt hours sounds like an impossible number, right? But here's the part that really surprised me. When you put it in context, it's only about 1.4% of the total energy the world already produces every year. It's a colossal amount of power, for sure, but it's a surprisingly small slice of the pie. To put it another way, all the energy for this project could be supplied by about 50 average nuclear power plants. That's a lot, no question. But the proposal makes the point that this is an industrial scale that is completely achievable with the technology we already have today. And how would they actually get all that salt into the water? The plan outlines two main methods. One is a huge network of underwater pipelines that would inject super concentrated salty brine right where it's needed. The other is a fleet of giant floating barges that could actually produce salt crystals on site and deploy them more flexibly. So let's say they pull it off. What would be the end result of all this? Well, the vision for this project goes way beyond just a simple repair job. It's framed as one of the ultimate infrastructure projects for the entire planet. If you restore the AMOC, the strategic impacts are profound. Europe would be shielded from that catastrophic cooling scenario. Africa would get back the benefits of the current's cooling effects. And most importantly, the whole planet's climate system would become significantly more stable. And the way they frame this is so important. They argue this isn't a climate offset, like planting trees or buying carbon credits. No, this is a direct, physical, planetary infrastructure project. We're talking about something on the same level as building a global energy grid or launching a space program. It's about actively managing one of Earth's critical systems. This quote, straight from the proposal itself, just perfectly sums up the ambition here. A once-in-a-century opportunity to actively stabilize Earth's climate system through decisive, science-driven intervention at planetary scale. I mean, that's a bold, and for some people, maybe even a scary new way of thinking. And really, that's what this all boils down to. The technology seems to be within our grasp. The massive energy requirement, while huge, appears to be achievable. But it all leaves us with this one profound question. Just because we might have the power to engineer our own planet on this scale, should we?